IITJEE.
Hi, Tabari Science Lab!
Alright folks, so let's take a more visual approach to the same problem we did last time. So we got the same thing. We got two balls, both starting from rest, but one has twice the acceleration of the other. They both travel the same distances, but we want to know the ratio of the times it takes for them to travel the same distance. Right? So let me draw it out for you in case you forgot. First ball, second ball, they both start at a velocity of 0. Vi is 0, Vi is 0. First ball has an acceleration a, second ball has an acceleration 2a. They both travel a distance of d, except one takes a longer time than the other. By how much? That's the question. So let's take a graphical approach. Here's what I recommend doing. Draw your own VT graph as such, and let's get started with this thing. How do we approach answering this question with VT graphs? So let me show you. I'm going to highlight all of this. Let me go ahead, highlight all of these, and highlight all of these clocks and races, and let's put them to the side for a moment. And let's look at this VT graph we got here. So we know both of them start at an initial velocity of 0. So first guy has a graph like this. Second guy has twice the velocity, twice the acceleration. So he has a graph like this. Now you might be thinking, why didn't I take the green graph as far as the blue one? Well, remember, since they're traveling the same distance, and the green one, this one, has twice the acceleration as the blue one, well, it stands to reason it would take less time for it to cover the same distance. Now, if the green one, say, travels for a time t, what would its final velocity be? Well, given Vf is equal to Vi plus At, and my Vi is 0, Vf would just be At, or 2At, since the green one has a velocity of 2A. So let me revise that, 2At, 2At. Now the question is, what's the time and velocity for the blue guy, for this one? Well, we know that it has to have the same area under its graph since they both travel the same distance. So let's use that to our advantage. What's the area under this green graph? How can we find that area? Well, that area is as simple as literally half. Oh, did I get frozen again? Oh gosh. Time for another blooper, folks. Time for yet another blooper. Let's wait for that. All right, the technology gods have forgiven us. Let's keep on going. What's the area under this graph? Well, it's going to be half BH. What's my base? Well, it's going to be the time, right? So it's going to be half of time. What's my height? Well, it's going to be 2AT. 2AT. And so if I multiply these two, remember my half and my 2 cancels out. I'm left with AT squared under my green graph. How about under this blue graph? What's the area under this blue graph? Well, that's not too bad. I don't know what my time is. I don't know what my velocity is. But we can use something to our advantage. We know that area has to equal this one. So let's use that. Let's say that this is some KT, right? We know it's going to be some multiple of my other time. So this is going to be KT. This is going to be K2AT, if you will. Okay, if you will entertain me on that thought. So actually, let me just name that. If this is KT, then this has to be what? KAT, right? Okay, good. So now we can set these two equal to each other. This has to equal half my base for the blue one, my base for the blue triangle, which is KT, half KT, times the height for my blue triangle, which is KAT. Almost like KitKat. So what do I have remaining? I have AT squared is equal to, let me do that in color-coded language so that it helps. AT squared is equal to, let's see, I have half K squared T squared A. And so my accelerations cancel out. My T squares cancel out. What am I left with? Well, let's see. I have 2 equals K squared. And so K is equal to square root of 2. And so our final answer is, huzzah, decreases by a factor of root 2. Hopefully that was as satisfying for you as it was for me. We'll check you out in the next lecture. If you have any comments, leave them below and we'll check them out in the next one.
Ambition plus MKO plus scaffolding equals learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.